sustainable rubber additives in rubber compounding. As we know, all our rubber compounding elements are hardly all are red chemicals. So we will be looking forward to his ideas and thoughts in next 20 minutes. Over to you, Dr. Das.
To come here, and I want to thank organizing chairman and committee to give this opportunity. So my topics is here. So it's nothing secret in this slide, no copyright. So but I need to go faster than Shinkansen, Japanese Shinkansen. Okay, so you can find my email address, and if you need this slide for better understanding, you can just drop a mail. I'll explain this one. So here I talk about the yes, not changing. Okay. Okay. So this is my research area. So first I just mentioned this one. One area, my conductive fabric, that was from ISRO project. I already developed the product, just conductive jacket. Now ISRO is working in the aerospace. And another project is food packaging, is a multi-layer, 3-layer material, which is equivalent to existing 5-layer film, polymer film, that is from the bark. So already technology transfer happened for that one. And another material, my subject is waste rubber or plastic recycling. This is the Ministry of Education. I got this project. And here I use the tire trade reclaimed rubber, and then we use the pyrolysis method, and is a waste no waste no emission method. Here we extract the oil, crude oil, and then crude oil we did the fractional distillation in the Indian Oil Corporation of India, Haldia, and we made the diesel-like oil, and it's we also calculate the cost. The oil cost per liter 67 rupees per liter without any tax. And here also we collected the pyrolytic carbon black. Already we filed for the patent, and several other area just like the carbon dot in there, another rising star carbon material, that is the several beauty of this carbon dot. I will explain little bit here. It is a very sustainable and is no health hazard. So we can, it is a beauty for antioxidant, curative, or several other application you can use it. And another project I did it, the EMI shielding, that is for DRDO project. And also we developed that rubber compound, and already technology transfer to the DRDO. They are using this type of material there. So here the rubber, so before go to different ingredient, you know all these major drawbacks. Major drawbacks means oxidative degradation, because it's a long chain molecule, some contain unsaturation, or so since it's a long chain and due to unsaturation is the degradation happen, and it's a creep flow or cold flow behavior is there, low mechanical state and little resistance to chemical and temperature range of application is very limited. So in order to overcome this project or overcome this problem, we need to add all the ingredient. Here I will cover some conventional one, but in place of that one, we try to highlight some sustainable and environmentally safe antioxidant. environmental sustainable filler or sustainable processing aid for proper processing, or eco-friendly curative for rubber compound, activator, accelerator, as well as the waste rubber as a additive. So there are several mechanisms here, and you know why polymer degrade due to presence of aging, oxygen, heat, several is there. And what happened in the degradation, if you see the radical generate, then radical to peroxide, then hydroperoxide, all these things is continually break the chain, and it go the low molecular weight. So we are losing all the performance or the properties. So what happen when it is radical generate, some of the polymer is go chain scission and is become soft, or some of the rubber is go cross linking and it's go the harden. So here another culprit is the ozone. They also react with our chain and is degrade. Okay. So if you look there, that the ozone is a surface phenomena, and oxygen can be the both surface and internal phenomena, and from visualize you can see what is the effect. So that role of antioxidant is the you can make a inert barrier. So different proposed theory is there. I mentioned here 3 theory: inert barrier theory, reduce critical stress theory, or chain repair theory. So for this one, we different kind of additive we are using as a antioxidant. So if you classify it, it is a primary antioxidant or secondary oxidant. And most of the existing oxidant, if you see, sometimes you are getting because it is a small molecule, it leads to the surface, and ultimately it's go to the environment, either in water, so through water, maybe fish, or in our food or drinking water, which is very dangerous for our health. So we need to go for sustainable things. So there are different strategy you can use it. So first is antioxidant, it should hold in the rubber, just means the anchoring the antioxidant onto the surface or reinforcing filler, because filler will be there. So that if you attach that antioxidant with the filler, it can hold in the surface, or you increase the molecular weight of the antioxidant so that high molecular weight cannot leach immediately on the surface, or macromolecular antioxidant, or environmental safe or sustainable antioxidant, you can use it. So here filler, so different kind of filler, see geo filler, graphene oxide, and then you can add different type of antioxidant attached to that filler, and that filler with antioxidant effective you can put on the rubber compound. In this way you can save our environment. Okay. And another one very common one, say lot of research are going on, and some of the company also making this one, and also using this one, that lignin, which is very good because it presents hydroxyl group, methoxy group, which act as a radical scavenger of any rubber compound. So you can use this one, and this is a technical academic. I collect this data from the technical literature. I did not validate this one, and it looks good because some preliminary work I did it, but not I don't show here data because it did not re-verify. But here some of the data I can show here. If you look here, the IPPD one antioxidant and the lignin, the antioxidant, first we use the IPPD, then lignin 2-PHR, then mixture of this one. And if you look the right side data, aging property, because the antioxidant should good aging property. So if you look this tensile strain, retention property, it's good after 72 hours aging test. And elongation black also you see very comparable. And another here lignin one, it is a natural rubber SBR based one, and with increasing different type of lignin. I put a lignin 1, lignin 2 because this is from different source, different property of the lignin. So here 3 type of material is there with our existing IPPD. So if you look here, the right side, the retention of tensile strain or elongation is very comparable. So lignin or lignin 2 or a mixture of this one. So you can slightly replace IPPD or completely replace the IPPD, which is health hazard or environmental hazard. You can replace it. So Another one which is EPPD, which is a mixture of 6 PPD and 7 PPD. This one sometimes it control the leaching, and you can use this mixture as a antioxidant for your rubber compound to save our environment. And another thing here, though it's I told you that the carbon dot is a rising star, is a very basically nanoscale 3 to 5 nanometer, and this material you can use, you can make from waste material, and it's a very sustainable synthesis. Only you need some water and some acid. There is no byproduct there, but its beauty of this one, it contains hydroxyl group, amine group, and sometimes it has acid group, and you can also dope here to enhance their effectiveness. So that one, if you mix with your rubber compound, it's make a good bond, and it prevent any kind of degradation, this carbon dot. So this is another good material there, and I put here some data here, real data. If you look here, the mixture of carbon dot with our existing antioxidant, and if you look here the property, if you look here the cure rate little bit faster because it contains some amine. That's why cure rate little bit faster. Otherwise, all the property is very comparable and is very promising material. And here some of the list here. So you can use antioxidant, lignin, caranol, and carboxymethylcellulose, T-fluoro. Some of the in the academic research stage, and some of are commercially available, and you can think about in application. So now we'll go for sustainable filler. Here I put the picture, what are the different filler are available we are using here, and maybe some petroleum product or maybe some sustainable product. So here, since I want to cover the sustainable, I try to select some sustainable filler. So in addition to the carbon black, so here the carbon black one, so everybody know this one. So is the very good material, especially for tire. But in order to go sustainable related thing, so we need to go little bit sustainable. We can replace the carbon black. Maybe 100% replacement for tire is very difficult, but maybe near future it may happen. So we'll go the sustainable thing. So there are several filler are available as a sustainable material like silica, nanosilica, clay, different type of clay, or cellulose derivative one, lignin one. Lignin also it can act as a filler, or it can act as a antioxidant. So 2-in-1, and the agilent or starch, calcium carbonate, so several sustainable, and I put their source there. So some of the academic interest literature available, some of the product also available. The different company maybe use this one. And I don't go to details on that one. The silica,
Das,
different type of
5 more minutes.
Yes. So different type of silica is there. So I don't want to cover the, you know, the different type of silica we are using, silica are using. And if you use the silica, we need the silent coupling agent to make a bond between the rubber and silica. Okay. Then another sustainable clay, we can use it. Different type of clay are available, so you can use it. Okay, so their characteristics here. Okay, so here calcium carbonate. So I don't want to cover here. Here I put one data here. If you use the lignin one, and if you check the property, is very comparable with the stress strain property. If you see it with the lignin, you can get the similar data. So here cellulose or cellulose derivative you can use as a filler. Till it is a academic, we are using as the academic purpose one. Maybe near future industry people can use this one, or you can start now. So nanocellulose, so different grade cellulose are available and specially used for NBR compound. And here whole scenario of the cellulose, because you can do some surface modification for better dispersion and better interaction between filler and rubber. You can do it. And here the bio-based filler, you can select. I put it here, all the scenario here, and this is data from this journal. You can select it and you can take it some of till you started the using all kind of waste filler. So here another one, carbon black. This is a pyrolytic carbon black, and that is we did it in our lab. From the recycle of rubber, and we use that carbon black, and we did several formulation, and then we tested, we study the curative, cure characteristic, abrasion resistance, and resistance property, and we found that only this carbon black contain higher ash, because when you pyrolyze it, it contains zinc oxide and other impurity, so that will go to the impurity of the rubber or ash content of the rubber. And here the process oil we are using. So this is the normal process oil, we are using common process oil, but here you can go for some sustainable process oil. So I put it here, different process oil, epoxidized palm oil, so I put also which rubber, which process oil, you can use it. These all are sustainable and environmental friendly and safe. And here another one, the bio-based process oil, we put here the data and the red marking, and if you check here rheograph, which give the cure characteristic, and also if you check the mechanical property, is very comparable. So you can go for this one, this bio-based process oil. Another data is here, so we did this work in our lab with Professor Noskar and myself, and we use this process oil in the natural rubber compound and PBR compound blend, and we got very good result. So it's a real data here, same one, we use other properties, and it's very good process oil, we can replace existing process oil. And then curing characteristics, we don't want to cover this one, already Professor Noskar covered this one. So I'll go which person is the sustainability. So here if you see here, zinc oxide, we are using activator, but here you can use the doped carbon dot. So that doped carbon dot, you can replace it, the zinc oxide, and it is act as a activator. So carbon dot act as a antioxidant, and here is a activator. So you can use it, and we put some real data here. Okay. So here several accelerators we are using here, but these all are generate some amine which is health hazard, and it is environment hazard. So you can replace on that one by some accelerator which does not liberate any amine or something. The phosphate type of this one, if you look at phosphate type, this type of accelerator does not liberate any kind of amine, so this is safe to use, and I put their cure characteristic. If you see, is very comparable data, so you can go for this one. And this one, another one, diallyl disulfide, which source is the natural source, the garlic or aluminum plant. So you can use this kind of accelerator for the rubber, which is sustainable one. And metal oxide, we are using this as zinc oxide. So here you can replace this zinc oxide by carbon dot. So we are using here carbon dot. Another here we can use as a curing material for the chlorophene rubber instead of zinc oxide. This is real data, and this is good for application point of view. So here resin curing, it's, you know this one, I don't want to go there. And another one for NBR rubber, that is the epoxidized soybean oil, and which is used as a self curing material for the compound and to save our environment. Okay, and here I put some data here. And then electron beam is not very common here because environment safety is there, safety issue is there, government safety issue, but you can use this one. Okay, so this is the conclusion. Host sustainable thing is there, starting from your antioxidant, then activator, and curative and filler. So overall, you can see here. And this is my group, research group, present research group, and this is okay. And thank you very much.
Thank you very much, Dr. Das. Well elucidation, but looking forward for more work on this sustainable subject.
Okay.
I think you people have to give a lead.
Okay.
There are topics like resin you have not touched upon well in this presentation.
Yes.
Okay. Thank you very much again.
Okay, thank you.
Thank you. I request Mr. Subir Sen to present the memento to Professor Narayan Das. Please put your hands together. Big round of applause for Professor Narayan Das.
Thank you.
Thank you very much.
Thank you very much.
As we
for
come to the end of technical session 1, I would like to request Mr. Mitesh Shah to please come on the dais and present the memento to the session chairperson, Mr. Subir Sen. Mr. Mitesh Shah. A big round of applause, ladies and gentlemen. This session was beautifully conducted by Mr. Subir Sen. So, well, ladies and gentlemen, now is the time for the lunch break. And the lunch break will be of only 35 minutes because we have to start the technical session 2. So 35 minutes lunch break. Use this time to recharge yourselves and network with fellow attendees. I request Mr. Ravi Gupta. I request Mr. Ravi Gupta to present the memento to Mr. Vinod Sharma. Requesting Mr. Ravi Gupta to please come on stage and present the memento to Mr. Vinod Sharma. Mr. Vinod Sharma is the editor of NoidaKhabar.com. Can we hear a big round of applause for him? Mr. Vinod Sharma, the editor of NoidaKhabar.com. So, ladies and gentlemen, we reassemble here right after 35 minutes lunch break, because we have to start with the technical session 2 at 2:15. So everybody be back right here at 2:15 p.m.